This is Shankar, Department of CSA. Now we will discuss phases of a compiler. Phases of a compiler. In the compiler, there are 6 phases. The phases are lexical analyzer, syntax analyzer, semantic analyzer, intermediate code, code optimizer, code generator. So here in phases of a compiler, there are 6 phases: lexical analyzer, syntax analyzer, semantic analyzer, intermediate code, code optimizer, code generator. The first 3 phases are called are under analysis part, and the last 3 phases under synthesized part. So the phases of a compiler, the total 6 phases: lexical analyzer, syntax analyzer, semantic analyzer, intermediate code, code optimizer, code generator. In that, lexical analyzer, syntax analyzer, semantic analyzer comes under analysis part. Intermediate code, code optimizer, code generator comes under synthesized part. So analysis part is nothing but front end, and synthesized part comes under back end. So there are 2 parts: front end part and back end part. Front end is comes under analysis part, back end part comes under synthesized part. So here these phases are between high level language to low level language. So here the high level language is nothing but like C, Java, all these comes under high level language. And low level language, the low level language is nothing but a mission code. So whatever the mission code, like binary zeros and ones, then it is called as low level language. So here the source code, high level language is a source code. The source code is converted into a mission code. Source code is converted into mission code. So between source code and mission code, there are 6 phases: lexical analyzer, syntax analyzer, semantic analyzer, intermediate code, code optimizer, and code generator. Along with 6 phases, there is a symbol table and error handler. So every phase represents with this error handler and the symbol table. So compiler, the phases of a compiler, it consisting of 6 phases along with symbol table and error handler. So lexical analyzer. So the lexical analyzer So the lexical analyzer will takes the input of high level language. The high level language is converted into stream of tokens. So the stream of tokens, for example, there is a high level language, C is equals to A plus B star C. So this is the statement, C is equals to A plus B star C. So here lexemes, the lexemes are C, equals to A plus B star C. These are all lexemes and tokens are C is here. C is identifier. Identifier is indicated with ID. Here assignment operator. This is equal. The equal symbol is assignment operator, and A is identifier, plus is addition operator, and B is identifier, star is multiplication operator, and C is identifier. So here the total statement is converted to lexemes, and all the lexemes are represented as a tokens. The tokens are any variable, any character. That character is indicated with identifier. Any operator, the operator, suppose there is equal. Equal is assign operator, plus is addition operator, multiplication operator. So the lexical analyzer, it will gives the stream of tokens. The stream of tokens like this. So that stream of tokens like C is equals to. So here ID equals to ID plus ID star ID. So in lexical analyzer, the statement C is equals to A plus B star C. A equals to B, A equals to B, C is equals to A plus B star C is converted into ID equals to ID plus ID star ID. And coming to syntax analyzer. Syntax analyzer. The syntax analyzer will take the input as ID equals to ID plus ID star ID. So this is the input of syntax analyzer. The syntax analyzer will generate a parse tree. The syntax analyzer will generate a parse tree. So here the syntax analyzer will generate a parse tree. Suppose ID plus ID, ID plus ID, again star ID. So this is equals to what? ID. So ID equals to ID plus ID star ID. So this is the parse tree generated by syntax analyzer. So this is the lexical analyzer will gives you output as stream of tokens. The stream of tokens will represented with identifiers, and the identifiers, these converted identifiers will take the input as syntax analyzer. Then syntax analyzer will gives you the output as syntax tree. And after syntax tree, semantic analysis, syntax analysis, semantic analysis. So the semantic analysis or analyzer, the semantic analysis or analyzer, it will takes input as parse tree. It checks whether the parse tree is meaningful parse tree or not. Meaningful parse tree or not. The semantic analyzer will check the previous parse tree is meaningful parse tree or not. Suppose I will take C is equals to A plus B star 20. So this is parse tree. This is equals to, this is plus A plus B star 20 equals to what? C. So this is the parse tree. So meaningful parse tree or not. So here there is a constant. It constant should be int or float. Suppose there is 20 point something 001. 20.001, it will get takes as data type as a float. It is purely 20. Then it will take data type as integer. So it will convert the 20. Sometimes it is integer, sometimes suppose if there is any dot decimal number, then it will indicate it through a float. So in the given parse tree, previous parse tree, it checks whether the parse tree is meaningful parse tree or it will checks in semantic analyzer. And the next one is intermediate code. So here the intermediate code always represents three address code. Suppose for example, C equals to A plus B star 20. So I will take T1 as B star 20 and I will take T2 as A plus T1. Then again, I will represent this C as T2. So the total statement is converted into three address code. So this is the representation in intermediate code. So this is the fourth phase of a compiler. After that, there is code optimizer. In code optimizer, suppose the equation is A plus B star 20. So here T1 equals to what? B star 20. T2 equals to what? T2 equals to T1 A plus T1. So here then C equals to what? T2. So here there is no need of this one. C is equals to T2. Here T1 is assigned. T1 is temporary location. In the temporary location B star 20. For this B star 20, add A. So A plus T1. So this is not required in code optimizer, so that we eliminate this statement so that we can optimize the code. So this is code optimizer. And coming to code generator. So what is code generator? Suppose the equation is A plus B star 20. A plus B star 20. So the code generator, suppose I will take A as R0, B is R1, C is 20 is R2. Then multiply R1, R2. So this multiply R1 and R2. Multiply R1 and R2 means what? R1 and R2 multiplied. The result is stored in R2. Then add R0, R2. So here R0 value is added to R2. Previously R2 consisting of what? B star 20. For B star 20, R0 value. R0 is A. A is added to B star 20 and the result is stored in where? R2. Then move. The total value is in R2. Then move R2 to C. So this is the code generator. So this is the 6 phases of a compiler. The compiler consisting of what? Lexical analyzer, syntax analyzer, semantic analyzer, intermediate code, code generator, code optimizer, and code generator. So this is about phases of a compiler.